Math 1314, Section IC1, Spring 2022, Tyler Junior College, Section 1.2, Linear Equations, Video 5, Clearing Fractions. Now, in a previous video, I believe it was video 3. No, it was video 2. One of the equations that we solved is this one that you're seeing here, 1/2 x plus 3/2 equals 7/4. And when we solved it using the standard moves for solving any equation, regardless of whether or not the numbers were fractions. We had subtracted 3/2 from both sides. We got that answer over there. And then when we got to the left side, we divided both sides by 1/2. But the problem with that approach is that every move involved doing math with a fraction. And although doing math with fractions is a skill I actually expect you to have, let's be honest. What's better than an equation that has 3 fractions? The answer is an equation that has no fractions. So when you're solving an equation with fractions, you have one of 2 options of what you can do. Do the math with the fractions all the way until the end, or get rid of the fractions at the beginning and then finish the problem. I think most people would agree that the problem would be easier if we could knock out all the fractions at the beginning instead of dragging them along, kicking and screaming from the beginning to the end. So this video is focused on how to clear out fractions. And it's actually not that hard if you remember 2 things. Number 1, every fraction is a division problem. And number 2, the opposite of dividing is multiplying. So keeping that in mind, if we can find a move that will help us cancel all 3 division problems, divided by 2, and divided by 4, then there will be no more division problems, aka no more fractions. So all we have to do is come up with a number that is capable of canceling dividing by all of those denominators. In other words, we need to multiply by something capable of being divided by 2 and by 4. And so what number is that? Well, there's a lot of numbers, but all we need really is a common denominator. Now, most people will say least common denominator, which isn't wrong, but any common denominator will get the job done. So our plan, if you will, is to multiply all terms by the least common denominator, LCD for short, of all the denominators, or all the fractions, I should say. So our plan again is to multiply all terms by the least common denominator of the fractions. Now, there is a process for finding the least common denominator of a set of denominators. And in another example, I'll bring that process to the surface. But in this particular problem, it might be pretty evident that the least common denominator is 4. In other words, I could turn all of these fractions into something over 4 just by multiplying correctly. For example, I could turn 3/2 into 6/4 by multiplying both sides of that fraction by 2. Or I could turn 1/2 into 2/4 by multiplying both sides of those fractions by 2. But let's work on the assumption that you found the least common denominator. Your strategy is to multiply everything by it, and it'll look something like this. Here's our equation. And now we're going to multiply both sides of the equation by 4. On the right side, there's only a single term, but I am going to put it in parentheses. However, on the left side, there are 2 terms, and I'm not sure if I've ever said this, but terms are separated by addition and subtraction. Technically, a term is a multiplication or division problem involving numbers and or letters. So 1/2 times x is a term, 3/2 is a term, 7/4 is a term, but you can spot them because terms are separated by addition and subtraction. On the left side, we have 2 terms, and we need to multiply the entire left side by 4. This will invoke the distributive property, but you can be proactive about it because distributing the 4 across the addition problem on the left basically means that each term is going to get multiplied by 4. So on the previous page, when I said multiply all terms by the least common denominator of all the fractions, That's because if there are multiple terms on one side and then you hit it with a multiplier, it will get distributed to all the terms on that side. All right, so now that we've done that, it looks messier, but what we've done is set up division problems that we can answer. At this point, you should focus on the numbers that you multiplied by and the denominators along with the fraction bars. For example, on the first term, we got 4 divided by 2. Now, granted, the 4 is not directly over the 2, but multiplication and division are kind of fluid when you do them together. So we can say 4 divided by 2. Similarly, on the second fraction, we'll have 4 divided by 2. And on the last one, we'll have 4 divided by 4. All of those division problems have clean whole number answers. So let's do all those division problems, shall we? On the first fraction, 4 divided by 2 is 2, or you can think of it this way. 2 goes into 4 2 times. Now, before we move to the next term, let's clean up what we have left in this first term. By completing the division problem, we now have a factor of 2 being multiplied by 1 and being multiplied by x. So all we have to do is multiply all that together. 2 times 1 is 2, times x is 2x. Bring down the plus sign from the next one. On the next fraction, which still has this highlight there, we are going to reduce by doing 4 divided by 2, or equivalently saying 2 goes into 4 2 times. And the exact same thing is happening on that second fraction. We're left with a 2 multiplied by a 3. Remember, we still got multiplication going on. 2 times 3 is 6. The last one's the easiest because the division problem is 4 divided by 4, which is the same as saying 4 goes into 4 1 time. 1 times 7 is 7. Now, if you had trouble following all the canceling multiplying, I suggest pausing the video, backing it up and watching it again, but it's a pretty straight process. You're setting up a multiplication so that you have a division problem that you can complete. Complete the division problem and multiply all the remaining pieces. And notice that the equation that we have left is a lot better than it used to be. It used to be 1/2 x plus 3/2 equals 7/4, but now it is just 2x plus 6 equals 7, which is easy to solve. Subtract 6 from both sides to get 2x equals 1. Divide both sides by 2 to get x equals 1/2, which is the answer that we had gotten before. We're just going to take a look at one more example, but in this one, I'm going to show you how to locate the least common denominator because it's not always obvious. Excuse me. Okay, we're going to solve 5/6x minus 11/16 equals 9/8 x plus 7/12. Have fun finding the least common denominator for 6, 16, 8, and 12. I invite you to pause the video to see if you can find it. I bet you can find a common denominator, but will you find the least common denominator? Before we solve this one, because once we find the least common denominator, it's going to be pretty straightforward. I want to show you how to find the least common denominator of any group of numbers. So we'll do that on the next page. Here you see all 4 denominators above each other, 6, 16, 8, and 12. To find the least common denominator of any group of numbers, the first thing you must do is factor each number completely. And by factor, I mean rewrite as a multiplication problem involving only prime numbers. For example, there's only one way to write 6 as a multiplication problem using prime numbers, and that's 2 times 3. But what about 16? Now, if you think of 2 times 8, 8 is not prime. And if you think of 4 times 4, 4 is not prime. But we can do this. We can make what's called a factor tree. To figure out the prime factorization of a number, start by writing it as any multiplication problem. For example, let's say that you say 16 is 2 times 8. If one of your numbers is prime, meaning that you can't break it down further, circle it. If it's not, break it down more. 8 is 2 times 4. 2 is prime, 4 is not. 4 is 2 times 2, both of which are prime. So the complete prime factorization of 16 is 2 times 2 times 2 times 2. It takes some legwork to get the least common denominator of some numbers, but all I'm doing is breaking down numbers as far as I possibly can. If you do the same thing for the number 8, you'll break it down into 2 times 2 times 2. And if you break down a 12, well, let's think about it. 12 is 2 times 6, but I can break down 6 into 2 times 3. And if you'll notice, I'm trying to write my prime factors in an increasing order, all the 2's before all the 3's. So let's say that you've broken down each number into its prime factors to build the least common denominator. And I'm going to type this: to build the LCD, take each unique factor, the most number of times it occurs in a given number. In a given, we'll say factorization, big fancy word. Take each unique factor, the most number of times it occurs in a given factorization. So we're going to start building our least common denominator. The first unique factor in all of these is 2. So we're going to use some 2's, but we have to use it the most number of times it ever shows up in a single row. And where is that? It's in the 16s. In order to make a 16, we have to use 4 2's. So our least common denominator requires 4 2's. That's the most number of times it occurs in any factorization. What's the next unique factor in our list? 3. It shows up in the 6 and it shows up in the 12. However, it only shows up once. It shows up once there and it shows up once there. So the most number of times it ever shows up is just once, which means in our least common denominator, we only need it once. So take each unique factor, the most number of times it occurs in a given factorization, then multiply it all together. If you multiply 2 times 2 times 2 times 2 times 3, you'll get 48, and that is actually the least common denominator. Now, you might think that's a lot of legwork just to find the number I'm going to multiply by, but trust me, it's worth it. Because now that we know the least common denominator is 48, we can go back to our equation and multiply every single term by 48. It's going to get a little tight in here. In fact, let me pause and space this out real quick. Okay, I spread everything out. And now let's multiply everything by 48. I'm going to go through the cleaning up of the fractions fairly quickly. I invite you to rewatch the video if you need to see it again. On the first term, I will highlight the first term for emphasis. On the first term over here, 48 times 5/6 x. It goes like this. 6 goes into 48 8 times. 8 times 5 is 40 times x is 40x. Next one's going to be minus. 16 goes into 48 3 times. Use a calculator if you weren't sure. 3 times 11 is 33. Equals. 8 goes into 48 6 times. 6 times 9 is 54 times x is 54x. And then lastly, 12 goes into 48 4 times. 4 times 7 is 28. Now, this doesn't finish the equation, but it does get us a lot closer to the end. So let's finish this off. 40x minus 33 is equal to, what was it? 54x plus 28. Okay. All right, we got too many x's. I'm going to get rid of the 40x by subtracting it from both sides. My decision was driven by the fact that when I do that, the x's on the right will end up being positive. I got negative 33 left on the left side. On the right side, 54x minus 40x is 14x, and then plus 28. Now to start getting the x by itself, we'll subtract 28 from both sides. That will cancel the 28s on the right. Negative 23 minus 38 is negative 61, equals 14x. And to avoid writing another page, we would divide both sides by 14. You'll get x equals negative 61 over 14. And I'll go ahead and tell you right now that fraction will not reduce. So if you are solving an equation with fractions, you have the option to multiply by a least common denominator to clear out all the fractions and then proceed.